Welcome to Pomodoro Joe for Monday, May 8th, 2023. Today we're looking at LeetCode problem 1572, matrix diagonal sum. This is an easy problem. So given a square matrix, mat, return the sum of the matrix diagonals. Only include the sum of all the elements in the primary diagonal and all the elements in the secondary diagonal that are not part of the primary diagonal. So that's just saying if this middle number here is shared by both diagonals, only include it once. All right, so this seems pretty straightforward. Let's put 25 minutes on the Pomodoro timer and we will get started. Okay, so we'll start with our result and we'll set it equal to 0 to start with here, and we will return our result at the end. So the key insights here are we have rows that range from row 0, row 1, row 2, up to row n. Now, in our first row, we'll grab element at index 0. So row 0 will grab element 0. Row 1 will grab element at index 1. Row 2, so on and so forth. So our row matches our column. That's the first insight. Now for the secondary diagonal, we're looking at the length of the entire row minus the row number. So for row 0, in the primary diagonal, we'll grab element 0. For the secondary diagonal, we'll grab the length minus 0. So that's this one here at the very end. Now if we go to row 1, we'll grab element 1 from the primary diagonal. But for the secondary diagonal, it's the length, which is 3, minus 1, which is element 2. So we'll have to do a little bit of fudging for the index factor. This is 0 indexed. This is length 3. So we basically say max index, which is max index 2, minus 1 to give us this element here in the middle. All right, let's just get started here. So I'm going to keep track of the lengths that we have. All right, so our maximum column, so in our matrix, it'll be row and then column. So row first, then column. It doesn't really matter in this case because it's a square matrix. But to be correct, I'm going to say the maximum column will be the length of the row index 0. And I'll say minus 1 because it's a 0 indexed array, but the length will be an absolute. So it's the length of the row 0 minus 1. So that's our max column. Next, we'll just go through every row. So for every row, and we want to keep track of which row we're on, so I'll call this like row index. And let's get the actual row and enumerate our matrix. So enumerate will basically give us both the row index and the row, maybe I'll call this row number, that'll be easier. All right, so the enumerate will go through the matrix, returning the row number and the row for every row in the matrix. So our result, we're going to end up with essentially 2 elements per row, one for the primary diagonal and one for the secondary diagonal. So let's just get these. All right, so this is a little bit ugly, but hopefully it makes sense. So we'll go through for every row in our matrix, we're going to get the row number and the row itself. Actually, interesting, we don't need this row number. We could just do row. Well, we'll clean that up in a minute. All right, so we get the row number and the row. Then we'll grab the primary element for the primary diagonal, and that's going to be at this row number and row number, because at 0 we get 0, 0. At row 1 we get 1, 1. At row 2 we get 2, 2. So that's going to be the row number and row number. That gives us our coordinate for the primary diagonal. Now for our secondary diagonal, we'll still get the row number. We're just going row by row here. But instead of using the row number for the column as well, we're going to get the max column count and we'll subtract our current row number. So that's going to be basically, in this case, 2 minus 0, and then 2 minus 1, and then finally 2 minus 2. Now, the one thing I'm not counting on here is this middle piece. So one thing we might want to do is we say it's primary plus secondary if, well, that's going to be if this max column, basically we're just looking for if both of these are not the same coordinate. Now, they're both going to be on the same row, but we're just looking to see if this row number and this max column minus row number are the same. So let's do this. Okay, so this is a little ugly, but I think it should work. So our result, we'll just add both the primary and the secondary if the row number is not equal to the max column minus the row number. Now you might be thinking, why do you do that? Well, we do that because we're looking just at this coordinate, row number, row number. So this is our primary. We're going to use the row number for both the row and it's both the x and y coordinates. Let's put it that way. Now for our secondary, we use the row number as our x coordinate again, well, and really the y coordinate. And then we use max column minus the row number for our y coordinate, or really the x coordinate in this case. So as long as these two are different, then we have different coordinates. But if these two are the same, then both our secondary and our primary share the same coordinate, which means we only want to add the primary's coordinate value. So in that case, we'll say primary plus secondary, but only if these don't match. Otherwise, we just add the primary. All right, let's go ahead and run this and see how we do. And we pass. All right, let's see if we can pass all of them. And we pass. We only do 32% for runtime and 5% for memory, so we don't do great. Let's see if we can do something else to improve on this. Long story short, we couldn't. Well, when I say we couldn't, I mean I couldn't. So I did try a bunch of different things. My main focus was on the if statement within the for loop, thinking if I move that if statement out, so we would, instead of checking to see if we had the same center square multiple times in our if statement, we would just add both of the center squares, the duplicate center square, and then outside of the loop, we would go back and subtract the duplicate center square if we needed to. Honestly, it didn't really make any difference at all, but I tried a whole bunch of times and a whole bunch of different options. Nothing seemed to make a difference. Our first score was our best score. So I'll leave it there and see if you can get a better score than I did. I bet you can. All right, well, I'd say that's it for me. Best I got here, I think, was about 32%. Yeah, it's the best one I got. All right, see if you can do better. I bet you can. There's a lot of room for improvement on this one. So hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.